Okay, in this video we'll take a look at problems that involve integrals using the inverse trig functions. And it'll wind up being three formulas, and they look like this. You'll have the integral that turns into the inverse sine, another one that turns into inverse tangent, and finally a third one that turns into inverse secant. Now, where do these come from? It will help if you go back and look at the derivative rules to start with. So real quickly, let's go back and look at the derivatives of the inverse trig functions. And if you look at the derivatives, here they are. Here's all six of them, but we're just interested in the three on the left. Now to start with, you had the derivative of the inverse sine turned into this, but look at the general form of it. The idea is if the derivative of the sine gives you this, then the integral of this should take you back to the inverse sine. Well, if you look at this form, again, it's the square root of 1 minus u squared, but you can think of this as being 1 squared minus u squared. And if you look at the integral rule, you've got the square root of something squared minus something squared. So if it's in that form, it will turn back into an inverse sine. Now you might look at this and say, well, this one's got a 1 in the top, where the derivative has a u prime in the top. But don't worry about that, because when we do u substitution, it will take care of this u prime in the top. So now looking at the next one, if you had the integral of 1 over something squared plus something squared, that will turn into the tangent because it falls into this form right here. Think of it as being 1 squared plus u squared, or something squared plus something squared will turn into a tangent. And then finally on the last one, if it's in this form, the integral of 1 over, you've got u times the square root of something squared minus something squared. This will turn into a secant because it looks like this form right here. So u times the square root of something squared minus 1 squared. So roughly, that's where these three integrals are going to come from. Now, the three on the right you don't have to worry about because, again, all they are, you just got a negative in front of it. And other than those negatives, these three are exactly the same as these three. So really, you can just work with these three rules right here. So that's where these integrals come from. And when we do the problem, it's really, the hardest part is recognizing which one of these three forms it falls into. So with all that, let's go ahead and try a couple problems and see how this works. Okay, now on this first problem, sometimes you have to use u substitution, sometimes you don't. In this first problem, we will not have to use u substitution. But the idea is, how do you turn this problem into something that looks like one of these three? Now to start with, it's closest to this one up here, and you've got 1 over the square root of something squared minus something squared. So you'd like to turn this problem into 1 over the square root of something squared minus something squared. Now to do that, you've got a 5 in the top instead of a 1, but that's not a problem because you can always bring the 5 outside the integral. So let's do this when we begin the problem. Okay, so to start with, I'll make this be equal to, and I will do that. I'll go ahead and bring the 5 outside the integral. So this is going to be 5 times the integral of, now what I'm going to do is go ahead and make it be 1 over the square root of, and the trick to these problems is this. You need something squared minus something squared. So rather than writing a 9, go ahead and write a 3 squared. Then rather than an x, go ahead and write an x in parentheses squared. Then you've got a dx. Okay, so what that does, you've changed it now into this form, and you want to make it agree with this rule. So you've got the integral of 1 over something squared minus something squared, and it agrees with this rule right here, so its antiderivative is going to be the inverse sine of u over a. So back to the problem, what I would do now, let's go ahead and do this, is what's inside this parentheses is a, and what's inside this parentheses is u. So we've got them in, again, in this form right here. There's a and there's u. Okay, now it's just a matter of finishing up the problem. So what this is going to be is you've got the constant 5, and then this thing turns into, using this rule, it just turns into the inverse sine of u over a plus c. So this will become the inverse sine of u over a, but u is equal to x, and a is equal to 3. Then just tack on a plus c, and you're done. So that would be the antiderivative. Now this problem did not require u substitution because you just had a simple x. And like everything else you've done in calculus, if you have something more complicated than just a simple x, then you have to use u substitution. So let's look at the next problem, and it will be exactly like this problem, but instead of x squared, let's put a 4x squared, and you'll see why you have to use u substitution. So this next problem is going to look like this. Now again, exactly the same thing, but you've got something other than just a simple x here. Now we'll start it exactly the same way. So we'll make this be, first of all, bring the 5 outside the integral. Then that gets you to this, which would be, now you have a 1 on top here. And I'll still do it the same way I did before. I'm going to rewrite it, and I would suggest you do this in all these problems, as something squared minus something squared. Well, this one, just like it was last time, this would be 3 squared. Then you've got minus, and instead of 4x squared, I'm going to write this as 2x quantity squared. And all this will be dx. Now, we'll go ahead and label things. What that's going to give me is this is going to be a, and this is going to be my u right here. But this is more complicated than just a simple x. So again, this is a problem where you're going to have to use u substitution, just like you've always done. So we'll do the u substitution over here. I'll let u be equal to 2x. That means that the derivative of u with respect to x would be equal to 2. So that means that du would be equal to 2 dx. Now again, I'm going to try to change this dx right here into a du. So there's the dx. I don't need the 2. I'll move the 2 over here. So 1/2 du would be equal to dx. And this dx agrees with this dx, so I can substitute. My u substitution will be that right there. So there's the u substitution, and that's no different than anything that you've done every time you've done u substitution before. So we'll go ahead and isolate this by putting a little box around it. So there's the u substitution right there. So now with that in mind, let's go ahead and plug in and see what we've got left in the problem. So this gets you to, here's 5 times the integral of, and this will be 1 over the square root of, and we'll leave this as 3 squared minus, but in place of this we're going to put u squared. And you've changed the dx into a 1/2 du. 1 du. So what you've done there is changed it from an x problem into a u problem. But for the formula to work, you can't have a more complicated x in here than just an x. So use u substitution. Now the next thing to do, take the 1/2 and bring it to the outside of the integral. So that's going to give you 5/2 times the integral of 1 over, and then you've got the square root of 3 squared minus u squared du. Okay, so finally what this does, this thing now agrees, look at your formulas, this thing now agrees with this formula right here. So you can change it into the integral of the inverse sine of u over a plus c. So this becomes 5/2, and this integral turns into, now again when you do this, remember your a is going to be 3 and the u is going to be 2x. So as I change this, this will become the inverse sine of u over a, which is 3, plus c. And you're almost finished. The last step of the problem, like you've done in all u substitution problems, is turn the u back into an x again. So the final answer would be 5/2 of the inverse sine of, and in place of u, put what it's equal to, 2x over 3 plus c, and you'd be done. So there's a first u substitution problem that involves the inverse sine. Now, in the next problem, we'll take a look at one that involves inverse tangent. Okay, now first of all, you got to figure out the form that it looks like. So what I'm going to do is do exactly what I did in the previous problem, and I'll rewrite this thing. So I'll rewrite it as, first of all, bring the 7 out in front. And this becomes the integral of, and we'll put the integral across here, line. So now I've got a 1 here. Now just a little trick on this. In that last problem, we had a perfect square here, and you could take the square root of 9 was 3. But what do you do if you have something that's not a perfect square, and it's still, you have to write it as something squared? So I'm going to rewrite this as this little algebra trick as the square root of 5 squared. So if it's not a perfect square, you can always write it like that. Then for the u part, I'll write this as, I'll change the 9 into a 3x quantity squared dx. So what this does, it gets it into, let's see which form now. You've got 1 over something squared plus something squared. So look back at your formulas, and the one that seems to agree with is this one right here. So 1 over something squared plus something squared is going to turn into an inverse tangent, and we'll use this formula right here. But again, you're going to have to do u substitution. So if you look at that, this is going to be what a is going to be equal to right here, and this is going to be your u. But again, it's something more complicated than just a simple x, so it's going to take u substitution. So let's go ahead and do that over here. So you'll let u be equal to 3x, so du dx would be equal to 3. Now again, I'm going to try to get rid of this dx and turn it into a du. So that means that du would be equal to 3 dx. And again, I don't need a 3, so I'll move the 3 to this other side. So 1/3 du would be equal to dx. And again, this agrees with this up here. So my u substitution is going to be that right there. So there's the u substitution for this problem. And again, we'll isolate this and make that be. So there's the u substitution right there. So now, back to the problem. This will turn into 7 times the integral of, and we'll put 1 over, now this one we can leave alone. Let this be the square root of 5 squared plus, and you've changed it from an x problem into a u problem. So this is now u squared, and this becomes 1/3. dx changes into a 1/3 du. Okay, next thing. Go ahead and take this 1/3 and bring it out in front, which will give you 7/3 times the integral of 1 over, and again in the bottom you've got the square root of 5 squared plus u squared du. Okay, now you went through all of that to turn this into the form that it agrees with. So what you needed was 1 over something squared plus something squared, and now you've got that in this form right here. So now we'll let that be equal to, this is going to be 7/3 times, and again just use your formula. The formula says it's going to be, first of all, 1 over a, so you'll have 1 over a, but remember a is the square root of 5. Then back to the formula, times the inverse tangent of u over a. So this will be times the inverse tangent of u over a, but a is the square root of 5. And then add on a plus c. And again, you're one step away from being finished, and the last step is always change the u back into what it's equal to. So this will wind up being 7 divided by 3 times the square root of 5 times the inverse tangent of, and in place of u, put what u is equal to. So 3x over square root of 5, and then tack on the plus c, and you are done. So again, it's just a matter of getting it in the right form. You needed to have it in the form 1 over something squared plus something squared so that it would agree with the tangent formula. Now let's do one more that involves secant, just so we cover all of them. Okay, now in this one, you've got the integral of 6x and square root of something squared minus something squared. So if you look at your list of formulas, pretty good hint it's going to turn in, it's in this general form right here, so it should turn into a secant problem. So let's go ahead and try that. Again, first step as always is to rewrite it. So what I'll do first of all is bring the 6 outside the integral. So this is going to be 6 times the integral of, and we'll go from here over to here. So it's going to be 1. Now here's x, and I've got the square root of. Now again, I'm going to turn it into something squared minus something squared. So this will become 5x quantity squared minus 1 squared. So you always want to write it as something squared minus something squared. Now let's go ahead and label what we've got here. So here is u. This is going to be your choice of u. And this is going to be a. And again, I'm basing it on this formula right here. So u squared minus a squared. So now, again, let's go ahead and this is going to be a u substitution problem. So starting with this, let's take care of the u substitution first. If u is equal to 5x, we'll do our u substitution over here. So let u be equal to 5x so that the derivative of u with respect to x would be 5. So that means that du is equal to 5 dx. Now again, your u substitution involves replacing this dx with a du. Well, I'll take the 5 from this side, move it over to this side, and that gives me 1/5 du would be equal to dx. So this matches up with this, and there's my u substitution right there. So again, we'll isolate that like we've always done, and there is the u substitution. Okay, now when you plug this back in, you'll have the following. You've got the constant 6, then I've got the integral of, and again, going from here over to here, this is 1, and you're going to turn all this into u. But you have to do one more thing first. Now notice, at the very first thing, you've got this x right here. So you have to turn that x into a u also. And the way to do that, I think we'll do it in blue down here, is this. If u is equal to 5x, then u divided by 5 would be equal to x. So you're going to have to use this substitution also. So when you change it into a u problem, you can't have part of it u and part of it x. It all has to be in terms of u. So what that means is this x right here will turn into a u divided by 5. So I've got a u divided by 5 right there. Then I've got the square root of, and this becomes u. So 5x, this will become u squared minus 1 squared. And then up here, dx will become 1/5 du. Now, as you work these problems, you have to keep in mind, look back at the formulas. You're trying to turn it into something. It has to be in this form right here. 1 over u times u squared minus a. But at the moment, you've still got this 5 in here that doesn't, and this 1/5 that doesn't put it in the proper form. So you got a little algebra to do. So this has become 6 times the integral. The next thing I do is take this 5 from the bottom and move it to the top, invert and multiply. So I'll take this 5 right here and move it up to the top, which will get me to this. So I'm just going to take this one, move it up to the top, and I've got a 5 right there. Then u times the square root of, and I've got u squared minus 1 squared. And then out here, I've still got a 1/5 du. Now, why did I move that 5 up? Because I'm trying to get it into this form right here. This u doesn't have a 5 on the bottom of it, so I need a u all by itself, and now it does. And by moving that 5 up, now I make this agree with there. Now for the next step, a couple things cancel out. Sometimes they cancel out and sometimes they don't. In this case, you've got a 5 in the top and a 5 in the bottom. These will cancel out. That one cancels out. And what this finally leaves you with is you've got the thing in the form that you wanted. So this becomes 6 times the integral of 1 over u times the square root of u squared minus 1 squared du. Now that finally exactly agrees with what's in the formula here. So it will turn into this secant. Now it begins with 1 over a. So let's go ahead and remember a is equal to 1. So first of all, you've got the constant 6. We'll put that on the outside. So there's the constant 6. Then using the formula, the first thing you need is 1 over a. So in our problem, that would be 1 over, and a is equal to 1. Then you've got the inverse secant of the absolute value of u over a. So this will become the inverse secant of the absolute value of u over a, but remember a is 1. And then put a plus c. And the last step of the problem is just to substitute u with what it's equal to. So those 1's cancel out, and you get 6 times the inverse secant of the absolute value of u, but u is equal to 5x. Then tack on a plus c, and took a little work to get there, but finally you're finished. So there's that one. Okay, so anyway, there's some example problems. Now remember, the first example did not require u substitution, but the next 3 examples, you have 1 of each type, and all of them required u substitution. And the idea is, if what's in here is more complicated than a simple x, then you have to use u substitution to make it work out right. So there's some example problems in part 1 of the video on how to find the integrals of the inverse trig functions.